Welcome back, Chem 101, to your second problem session. Today we're going to be doing two things. We will be reviewing questions from the exam that some people had problems with, and then we will also be looking at selected questions from the book to give you a sense of the types of questions on your next exam. Otherwise, the exam went pretty well, as you'll probably hear in class later today. Mostly there were problems, it seemed, with units and unit conversions, and so we'll practice some of those. This is generally where I will go through the exams rather than in class. Otherwise, I was pretty happy with the results. It was probably a little easy, so expect perhaps a slightly longer and slightly more challenging exam as we move forward. And so without further ado, again, we're looking at the first exam that you guys just took. You were pretty good about looking at chemical and physical properties, and so now we'll begin to look at some of those math problems and some tips and tricks how you might use to solve them if you need. Let us start with, in the conversion section, problem number 4b. So just a density problem, or a conversion problem, you might say. The question asked, if I, myself, weigh 70 kilograms, and was made completely of silver, which again is Ag, that atomic symbol, with a density of 10.49, kilograms per liter, what is my volume? And so a couple things we can see, right? Here we have an extensive quantity, right? This is the amount that I happen to weigh. Any other person might weigh something else. Whereas the density of that material I made out of, silver metal in this instance, is going to be fixed. That's the same anywhere in the universe, and also, importantly, for any metal that you might work with in that way. So again, we have the extensive and intensive property, and we're going to come out with another extensive measure in just a moment. And so there's a couple ways that you might realize the equation that we're going to work with. We talked briefly about the triangle, right? The mass, volume, density. And so if we want density, we can cover up the D and see that it's m over v. So our equation can become... But we also can look at the units, right? So we know, for example, that we have units of kg, and we're going to be using the units that we were given, meaning that something's missing from here. And so in this case, we're going to be looking for, the units here are kilograms per liter. And here we're going to find that volume in liters in that way. So I think one of the hardest parts of this question for some was just that we wanted the volume, but here it was on the bottom of our equation. And so what we can do to write it out kind of explicitly is if we multiply the volume by both sides, so taking that equation we had, we're going to come up with essentially that equation that we need. So in this case, the v's will cancel out. We multiplied it on both sides, now they're gone. And then we can do the last step where we say divide through by density. So to make that, again, more explicit, we're going to take the density times the volume divided by the density is equal to the mass divided by the density. Am I off the board yet? Not quite. Let's go up here. And last but not least, we have the volume. Again, what we're looking for is going to be equal to the mass divided by the density. And so to fill in our values for what we have here, the unknown volume is going to be equal to the mass that was given, divided by the density that was also given. And so we can see here, right, 70 divided by about 10 should be around 7. I think 6.67 was the answer that we got in terms of liters. We have 3 significant digits. We have our units as well. So here we've gone from a known mass to a known volume via the density, right? And we can see how if you put the mass in, you can get the volume out in that way. And so again, a couple ways to get this equation. You can memorize the triangle, for example, and that will be useful for any of these transformations, right? Here we wanted volume, so we divided mass by density. Conversely, you can look at the units, like we discussed, and I think I erased, and then you can also get to the same equation there. Okay. And so what I would say is practice a couple of these. Practice some where you have just the density and the mass, just the mass and the volume, and just the volume and the density. And then you'll probably feel pretty comfortable with these. And we'll see different forms of these equations later on when we start to talk about gases and other things. Okay, now let's look at our second question. We're going to look at the 4C. And so this question gave you a value, in this case 150,000 kilograms per meter cubed. Slightly different unit than we saw, right? We know meters cubed and liters are not the same thing, though they are related. And the question was to go from this value for the density of the sun all the way to units that are sort of more practical in lab, grams per centimeters cubed. So a couple things. We're going to need to transfer not only the kilograms to grams, but also the meters to centimeters cubed. So let's set this up. First thing I can do just to make some of this writing a little easier, I will write it out in scientific notation. So 1.5, right? I'm moving the decimal place all the way from here over. So 1, 2, 3, 4, and 5 kilograms per meter cubed. That's the same version of the number that I'm starting with there. And we'll set up our dimensional analysis in just a moment. So we have 1.5 times 10 to the 5 kilograms on top, meters cubed on the bottom. Right? So it looks a little different than this number here, but this is another accurate representation of what we have, right? 1, 2, 3, 1, 2, 3, 4, 5. I always have to double check 2. Okay, so we're going to first try to get rid of those kilograms. So we'll put kilograms on the bottom, so they cross out. We have 1 kilogram is equal to 1,000 grams. That's one of the ways that we define these systems. So now, conveniently, we're already in grams. Now let's begin to look at the units that we have down here. So we know that we want to get rid of one of these meters cubed, but we also want it in terms of centimeters cubed. So let's take a quick pause and look at the relationship between those. We know, because it was on the back of the test, that 100 centimeters is equal to 1 meter. And so an easy mistake to make is that 100 centimeters cubed is equal to 1 meter cubed, but that is not true. If we want to go to meters cubed, we can take the cube of 100 in this case. So you have to cube the whole thing, not just the units. And then here we have the cube of 1 is still just 1 in that way. So what is 100 to the third power? Well, you could do 100 times 100 times 100. I also like to count the zeros. So 1, 2, 3, 4, 5, 6. Or 1 times 10 to the 6. Let me just pause there.